G'day everyone. I thought that while you were waiting for the new track to get set up, I might tell you a little bit about some of our tactical drones. My name's Kieran. I'm qualified on a couple of them, not all of them, but I thought I'd start with the smallest one in the Australian Defence Force inventory. Can you even see it? It's pretty tiny. This is called Black Hornet. The third variant, so we call it Black Hornet 3. It is what we call a nano uncrewed aerial system. So it's really, really small. It only weighs 33 grams. And this is the leading edge of our tactical systems that we use in the Australian Army these days. We equip every combat platoon in the Australian Army. A platoon is about 30 people. And those 30 soldiers, they have weapon systems and communication systems that allow them to affect the battle space out to about 2 kilometres. So we buy them a drone that can go out 2 kilometres to go and find bad guys, clear terrain, go and clear buildings, those kind of things, because we want to keep our soldiers. And the way to keep our soldiers safer is to not send our soldiers. We send them to go do it instead. The Black Hornet is fine, and you can see all the standard features that you would normally expect on a helicopter with a main rotor blade and a tail rotor blade, giving it lift and directional control and yaw control. And in the front, you can see 2 tiny circles. Now, if you are used to looking at the backside of your phone and thinking about the cameras that are on there and how small those lenses are, that's what you see here. They're just really, really small camera sensors that you might be used to seeing on your camera phones. They're really hard to see. You can hardly see those circles, right? So really, really small camera lenses. And that's how they keep the system down to be so lightweight. Like I said, 33 grams is all this aeroplane weighs. It flies for about 20 to 25 minutes, depending on how windy the conditions are. And with the antenna, I know it's going to be really hard to see, but this tiny little whip antenna on the back, that's how it talks through a radio link back to the controller. And Andy's got one of the controllers up there, and you can see the kind of imagery that, that our operators get to help make tactical decisions. Now, the idea here is that if you want to go and look at something that's 2 kilometres, up to 2 kilometres away, you can, instead of sending a soldier downrange to do that, you can send a little flying robot to go do that for you. So if you want to go down into an intersection and make sure there's no danger there, you want to go over a hill, you want to go down a creek line, you can do that. Now, Alex is flying one now inside, and it's going to be really hard to see because it's really, really small. And you won't hear it because it's so quiet, but definitely try and find the Black Hornet that's flying there. Only, 6 metres away to your front? And that's one of the reasons why it's such a great tactical system. When you launch it, it is so quiet and so small, it's actually really hard to detect. Even if you're looking for a UAV, they're really, really hard to detect. Now, like I said, every one of our combat platoons, every group of 30 soldiers in a combat environment in Australia, in the Australian Army, they're equipped with this system. And I got to tell you, the soldiers love flying it. Now, every platoon has, in that group of 30 people, 2 people will be qualified on the system. It takes about 5 days to learn how to fly it and then employ it. Flying an aeroplane is actually pretty easy, but then learning how to tactically employ it, how to sneak up onto a building, how to go and do tactical reconnaissance at the right altitudes, how to do pre-planned missions, that takes a couple of days extra. So we train our soldiers with about 5 days worth of training for this system. Now, the other feature that I really want you to look for here is, Andy's got the airplane, and he's got the little fold-down screen to see what's going on. The other thing that you want to look for is what's in his hand. So there's a little single hand controller in his hand there. It's all flown by that. So there's a series of buttons at your trigger finger, at your thumb, that tell you that tell the airplane how to fly, where you're going to send it. You can do all the pre-programming by GPS coordinates with those controllers. And the hand controller is really important. So you might be used to seeing a DJI product or some other drones around that you take 2 hands in both your thumbs to use. That's not great in the battle space, because if you're looking for threats within 2 kilometers of you, those threats can probably see you too. So you want to be able to defend yourself. Now, this system has been designed so that you can keep one hand on your weapon so you can protect yourself, and then use your other hand to fly the drone. And it's been specially designed like that. So you won't see this kind of design in any of the drones that you buy at JB Hi-Fi or Harvey Norman or places like that. Are there any questions about the Black Hornet? It's pretty cool. I gotta tell you, it's really fun to fly. And our soldiers really like being able to take something that they're used to flying on their PlayStation, on Call of Duty or whatever, and actually having it in their hands on the battlefield. So the individual price, I don't really want to say that number. What I can tell you is to fit out our whole army, every combat platoon in the army, it was an $18 million program 4 years ago, and that included all the training, all the spares, all the support, and that gave us the ability to train up about 300 operators and get a significant amount of systems out into the Australian Army. All right. I'm going to let Alex keep flying and Andy keep walking around, and then I'm going to show you another drone, a bit bigger drone. This is called the Wasp. So I talked about a combat platoon before, getting the Black Hornet. When you group 3 combat platoons up together, you get a combat team or a company of infantry. So that's about 100 soldiers. And every 100 soldiers has the ability to influence about 5 to 10 kilometers worth of the battle space. So we go and buy them a bit bigger drone that can look out to about 5 to 10 kilometers, depending on that terrain. And that's this guy. This is the Wasp. Now you'll see that if you're flying out at longer distances, you probably need a bit more battery, and you probably need to fly longer because you've got longer to get out there, then look at the targets, and then you've got to come home again. So you've got a different design of aeroplane here. We don't want to use helicopters for that mission. We go for something that's more conventional. If you put a big wing on it, you don't need as much power from your propeller, and subsequently we get a design that's fairly what you would expect to be a normal aeroplane. Now, some of the features that I want to point to here, you can see the camera system on the underside. This one, instead of being a fixed camera like the Black Hornet, and the Black Hornet can be fixed because you have complete 6 directions of freedom control over that plane, this one's always going in a straight line. So you need the camera to be able to move to look at the things that it's flying over or past or around. And that camera has 2 lenses on it, again, about smartphone size. You look at those lenses, you might think, latest Samsung 21, 22, 23, that's about the size of the camera technology that's on there. And you can see there's 2, that means there's a daylight camera and an infrared camera. So this one can go and find just as many targets at night as it can in the daytime. It's a really interesting aeroplane because while it's fairly conventional to get it up into the air, and by that, I mean the pilot runs up to full power and then literally piffs it up into the air like a glider, throws it up into the air. But you can't just bring a plane down like that, and that's where we need to talk about this other interesting, which looks like just a big piece of sponge. That's because drones like this undertake a really interesting aerodynamic move that we call a deep stall recovery. And that means that once we pre-program the spot where we want it to come back in, it drops its altitude down to a lowest safe altitude. And then as it approaches that recovery point, it actually pulls straight up in all of its forward velocity. Once you take the forward velocity, then you've taken a lot of your kinetic energy out of the aeroplane. It drops its nose back down, and then it just crashes. And that's what the sponge is for. It's just a big sponge as a cushion because we want to reduce the impact of that aeroplane. You'll notice there that the camera's pointing up. So it flies around on a mission like this, and then as it approaches that recovery point, it flips its back, does the deep stall, and falls to the ground, and it protects the camera. The camera is about cost of the aeroplanes, the bit we really want to protect and make sure it's good to go to the next. The Wasp is generally out to about 7 kilometres, and it flies for about 45 minutes. So to do that means that if we want to go and look at a target out at about 7 kilometres, we spend about 5 minutes getting out there. We can stay over the target for about 20 minutes, and then we can bring it back. It's also got a really cool feature in it. You can see, can you? I think one of the antennas is broken. This written off one, it's been very battle proven. You can see lots of sticky tape and super glue on it. One of the antennas is snapped off. It's also got a feature called air data relay. So if we want to fly it even further, we can launch 2 at once. We can send one to about 7 kilometers, and then we can send the ground control station's commands through that aeroplane, push it out another 5 kilometers. So we can have eyes on target out to about 12 kilometers all up. It's a really cool aeroplane. This one takes about 2 weeks to train a soldier on. Again, it's pretty easy through the base, but learning all of those really cool features like air data relay and how to do covert reconnaissance, what kind of altitude to stay at, to stay out of eyesight and ear sight distance, so you can stay undetected. When it's operating at about 300 to 400 feet, you can imagine that's quite small to the naked eye. It really just looks like a bird cruising around. What you see up there is just a black silhouette that's quite bird-like. And that's why it's got that really interesting tail configuration, really thin stick that comes back to the tail T, and all of that bit. That just blends into the background. All you really see is the wing, and that just looks like a bird tooling around and floating around at 300 feet. Anybody got any questions about the Wasp? We've got about 70 odd systems of this in Australian Defence Force inventory to equip all of those combat teams and our special operations forces. What's your question? So the camera on the top is a landing sensor. So it's a landing camera. So when you do that flip over, the pilot still wants to be able to see the ground. So it's a much smaller camera, lower fidelity, but it's just so that you can see the ground when you're about to do that move and then hit the bottom. Because as you approach that site, if all of a sudden a car drives onto it, people come onto it, you want to be able to see that and do a wave off and go around again. So it's like a 50 camera. I just pulled off one of the wingtips just to show you how simple it is to assemble and disassemble. It really is made for the battlefield. Anybody just plug and you can see a lot of just battlefield sticky tape on it. Any of those small surfaces that get a crack in it, the repair kit literally is a roll of sticky tape and some super glue, and we can generally keep these airplanes flying for a little while. That's a really good question. This drone, once you put a battery in it there, it weighs about 1.4 kilograms. So it's much heavier than the Black Hornet, but that's because it's got such a big battery in it to keep it powered, and because once you're higher, you need a better camera for looking at things. So the camera's much larger, and that's where most of the weight is. It's right in there. It's a really good question. Any other questions? Cool. I hope they're not too far away for you, and I hope you found that really interesting. Thanks.
Getting very close to finalising our training. In fact, I get the thumbs up from the track design. open class racing. Co-designed by Thomas Igniter, perhaps one of the fastest pilots in the world, designed alongside Hot Glue, one of the worst pilots in the Royal Australian Air Force. So it should be balanced, fair for everyone. We should have some good racing. Over here we have Julian Cookman in front of me. He has the Blackbird out. Black Hornet, sorry, I'm learning. Thomas said they're putting the final preparations onto the track. What we will do is we will get all our pilots out here into the arena.
Sorry? You're in like the 6th group.
Sorry.
That's ages away, yeah? Yeah. And I'm in with Raph.
You're behind the box.
Some of them. Put me in with the worst. Put me in with the worst. Doesn't matter.
We'll conduct our track walk, and then we'll get straight into the racing.
And no Noel?
I tell you what, that Black Hornet is hard to see in the arena.
Is Noel coming still?
It is so small.
No, he didn't.
It's just right here in front of me.
He started making all these excuses. I can't see tickets. He goes, oh, great. Daniel's not coming. Sorry, I should have told you earlier. Oh, Lee pulled out as well. Turn him down a bit? I just did. Oh, right, you did. Just a second ago.
Okay, all our pilots can make their way onto the track.
No, it's not my control, not my microphone.
Oh, right, okay.
I have no control of the volume.
It's Danes, is it?
Yep.
We have almost 60 pilots participating in open class racing over tonight, tomorrow, and Sunday.
I might get
Finals.
started
The
and then go
competition
get
will
something
culminate on
myself,
Friday.
Put him
The final series, our top 16 pilots in the double elimination final.
At this point, yeah. Probably just a hot dog even.
Fuck, that's shit food, man. You eat lamb or no?
A little bit.
Oh, okay. I'm not a lamb guy.
I don't mind lamb chops and lamb roasts and stuff, but not necessarily lamb in a kebab thing, right? What's the other meat they have in a kebab? Chicken or pork? No. Whoa. Falafel? No.
Falafel? Falafel?
Oh, I can't stream. I've got no data. There's too many people now. The cell towers are
Timmy, would you like to make your way out?
flogged out.
I'll get you.
Okay, I'll be right there.
You want chips, Timmy?
Yeah, maybe some chips will do.
Coming.
Rightio, if we have any stragglers, then they can just learn it on the fly. Thomas, welcome. Would you like to take us through your track?
Okay, let's do this. Hopefully I'm holding the mic okay. But yeah, also thank you for helping with setting up the track. I tend to be pretty sort of specific with these things, so thanks for bearing with me. But start blocks are in the same position as before, and the start gate is the same. So launching out of there, straight through into a sweeper section. And over here you can basically just focus on keeping a perfect line, because you'll be going straight through this gate and ascending into a right-hand spiral. So straight through like so, all the way up. And now go straight above this gate, staying high and heading towards the next spiral. This is a lower left-hand spiral, so starting from high. And then just trying to manage your altitude as you slowly spiral back down and through the gate. Over top first, correct, yeah. So you start low, stay low, then you spiral up, stay high, and then spiral down. So sort of like the altitude level you're at, you sort of stay on, unless you spiral. From here, a sort of half hairpin into a pretty aggressive ascent. And over here, we're climbing really high up. Be mindful to stay above these flags so you're away from the other race line. And once you're high up, I'm using the actual lights as a reference, but you're staying above these orange flags. So the lights are about where it is. The flags actually sit a little higher. So if you stay a little high, then you're safe. Over the top, a really high-speed sweeper section. Take note that the actual circus tent sort of tapers in. So the closer you hold to the poles, the sort of more altitude room you have to play with. And this is pretty much the same as what we had in the first track, the MIDRT track. From here, we have a splitter section. You can split us at left or right, it doesn't really matter, as long as you start high, which you would have been from the sweeper, and come down. I'll probably be turning right into this, just to give me a little bit of room from the top of the circus tent. From here, we have a short high-speed section. medium right-hand corner. No gates to worry about. You can send it as hard as you like. Just be mindful we are moving into a power loop or a slalom. It can be whichever one you want, but I think power loop will be the easiest to do consistently. For anyone who's uncomfortable with that, you don't really have to worry about it as a sort of traditional power loop. The main thing is going through this gate, entering this way, and then entering the next gate the same way. If you're going to do sort of like a 360 or something, just be mindful not to overlap on someone else's line. Try to keep a bit of altitude separation. So you can take it as a power loop, as a slalom, or if you want, you could even sort of take it steppy. So go through 180, go up, come around this side, 180 and through. As long as you're entering through the gates the right way and sort of not getting in the way of traffic, you're fine. From here, another high-speed sweep into kind of a medium hairpin. You can carry a ton of speed here, and I've tried to mark out the safe race line. So if you use the cones as a reference, you'll be at a pretty good position for a quick lap. And then here we slow down a bit, we've got a gate, and it's deliberately placed pretty early because you're about to turn onto the most high-speed section of the track. From here, no gates until the start gate, a massive sweeper into a small straight, basically hold on as much throttle as you're comfortable, put on a good show for the spectators, and yeah, go fast and have fun flying drones. That's one lap.
Thank you for that, Thomas. So from what I got from that, we should see a lot of high speed in front of our crowd and a lot of crashes coming right for you guys right now. Okay, pilots, please make your way back to the pits. First up, we will have Marzi, Tilted, Yui Wet Wet, Chiz, Top Knot, and Third Eye. We have Sticks Up Racing very soon.